Hello everyone. Topic is similar triangles. We have a postulate and two theorems to do first and then a few examples after that. And these are ways of, without going through like we did the last time, going through every side, the proportionality of all the sides, or without going through every angle. These are shortcuts that we can use that will conclusively prove that two triangles are similar. The first one is postulate 6.1 from our book, is the angle-angle similarity. And it says if the two angles, we'll fill in the blank here, if the two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. Notice I didn't say the triangles are congruent. I said the triangles are similar. They are the same shape, not necessarily the same size. And that conclusively proves that two triangles are similar. So if I have triangle A, B, C here, and up here I have triangle D, E, F. And I know that triangle A, or angle A and angle E are congruent. And I know that angle D and angle C are congruent. Then I know that triangle ABC is similar to triangle. Got an announcement.
Victoria Wiles to the Encore office.
I know that triangle ABC is similar to triangle EFD. And you want to keep the correspondence there. E goes with A, F goes with B, and D goes with C. So you want to keep that order. Now notice the similar symbol as opposed to the congruent symbol. Congruent means the exact same size. Similar means the exact same shape. Now, theorem 6.1 is the next one. It is side-side-side similarity. And it states if the measures of the corresponding sides of two triangles are proportional, then the triangles are similar. We don't even need to know what the angles are if we just know that the sides. So let's draw another triangle there. Let's draw one of these here. Okay, let's label this one GHI and this one JKL. Okay, basically what it's saying, and we'll just, in the obvious way it's drawn, if GH over LJ, the length of this side over the length of this side, is equal to HI over JK, the length of this side over the length of this side, which is also equal to IG over KL, if all these three ratios are equal, the corresponding sides, they make proportions, then triangle GHI is similar to triangle LJK. All right, one more. That's the side, side, side. We're going to do side, angle, side. Similarity. If the measures of two sides of a triangle are proportional, equal ratios, remember, to the measures of two corresponding sides of another triangle, and the included angles are congruent, included meaning the angle between the proportional sides that we're talking about, then the triangles are, once again, similar. S-I-M-I-L-A-R. All right, so in this case, I don't know why I'm drawing the same way every time, but that's all right. M, N, O. And over here, let's draw a littler one. P, Q, R. Now what I know about this is, suppose NO, that length, over QR is equal to MO over PR, and it's got to be this angle. Angle O is congruent to angle R, then triangle MNO is similar to triangle PQR. Now it had to be this angle if these are the sides that we matched up. That's the included angle between these sides. All right, well, let's look at some examples. Example 1. In the figure, AB is parallel to DC, BE equals 27, DE equals 45, AE equals 21, and CE, which is where? Right here, equals 35. Determine which triangles are similar. Well, before I go on here, I want to mark, if that's 27, and these two are marked congruent, so AB is 27, this one's 45, and CD is marked congruent to that, so this one's also 45. So what I want to do right now is kind of match up the sides. AE is 21. It matches CE, which is 35. AB is, and I'm going to put a question mark. Let's see if they're equal. If they're not, this isn't working. AB is 27. I'm going to match it up with CD, which is 45. And, well, I do know the other one is 27 over 45. So we know these two guys are equal. Is 21 over 35 equal to 27 over 45? Well, it just occurred to me that I don't have my calculator handy, and so I'm going to have to simplify this a little bit. But if all three of these proportions, all three of these ratios, I should say, are equal, then everything's proportional, and then these two triangles will be similar. So 21 and 35 have 7 as a factor, so that's 3 over 5. 27 over 45. 9 times 3, 9 times 5 is 3/5 and 3/5. So they all equal 3/5 in their simplest form. So they are all proportional. They all equal. Cross off my question mark. I'm not questioning that anymore. So triangle ABE is similar to triangle ABE, CDE. Those are the two that are triangle, and we used the three sides. Side, side, side similarity. All right, next example. I think we have to find something this time. Given RS is parallel to UT, RS equals 4. Let me put a 4 there. RQ equals x plus 3. I'll put x plus 3 right there. QT equals 2x plus 10. UT is equal to 10. We need to find RQ, okay, and QT. Okay, we have x's there, so we got to figure out what those x's equal. So, RS is 4, that one's 10. What I do know is if these two lines are parallel, angle R and angle T are congruent. And what I also know is angle RQS is congruent to angle UQT because those are vertical angles. So, by the angle-angle postulate 6.1, these two triangles are similar. And that would be triangle RQS is similar to triangle RQS TQU. Triangle TQU. I'm just trying to match them up. And I had to think about that for a second. So that is by the angle-angle similarity. We have two angles that are congruent to each other in the two triangles. So that means we can set up the sides to be proportional. I think RS, being 4, corresponds to UT, which is 10. So I'm going from the little triangle to the big triangle, and the little triangle has an x plus 3 in it. The big triangle has 2x plus 10 as its corresponding side. So if it's similar, the sides are proportional. And let's just finish the algebra. 4 times 2x plus 10 equals 10 times x plus 3. And 4 times 2x is 8x, 4 times 10 is 40. 10 times x is 10x, 10 times 3 is 30. Let's keep solving. Minus 8x, minus 8x. I got 40 here, 2x plus 30 here. Minus 30, that's 10. 2x, those cancel. Divide by 2, and 5 here, x here, because those 2's cancel. So x is 5. Well, if x is 5, this is 2 times 5 plus 10, which is 10 plus 10. So QT is equal to 20. And if x is 5, that's 5 plus 3. RQ up here, RQ is 8. All right, I will stop with that right now. I have one more, and you can print it off, but I may just save that example for class. And I look forward to seeing you then. Goodbye for now.